parallel adder. 4-bit parallel adder. So 4-bit parallel adder, how many full adders required? So 4-bit parallel adder means what? A have 4 bits, A3, A2, A1, A0. B have 4 bits, B3, B2, B1, B0. Getting? A have 4 bits, B have 4 bits. So now 4-bit parallel adder. So in this, what? How many full adders required? 4 full adders required. 4 full adders required. Okay. So this is a C0, A0, B0, sum 0 ladder. So this is C1. This is A1. This is B1. Sum 1. This is C2. A2. B2. C3. Sum 2. A3. B3. C4. Ready? So this is the 4-bit parallel adder. 4 full adders are required for this. 4 full adders are required for this. For suppose A, if I will 0 1 0 1, B 1 0 1 0. For suppose if it is like this. So I want to add these both numbers. Okay. So A 0, here A is 1, B is 0. 0 1, what it will get? 1, right? Sum will be becomes 1. Yes or no? Sum will becomes 1. Previous carry here it is 0, so it will becomes 1. What is the carry? 0, right? Carry will be 0. 0 0 0 1. What is sum? Sum is becomes 1. Sum is 1 means if this one is 0, this one is 0. Carry already 0. This carry also 0. This is sorry. B is 1. This carry also carry already 0. A is 1. B is 0. So then what is the sum? 1. Carry is 0. So now carry is 0. So what is A equal to 0? B equal to 1. So what is the sum here? 1. Any carry is there? 0. This is the result you will get. Ready? So this is the adder. So now see. This is added. Okay, after this added, carry is generated or not based on that only. So this is working, right? So keep on bits are increasing. So then what happening? Keep on delay is adding. For suppose one full adder takes to carry generation 5 seconds, 5 nanoseconds. One full adder will take to carry generation 5 nanoseconds. So therefore 4 full adders. 20 nanoseconds to complete the task. So keep on bits are increasing, the number of processing bits are increasing. So then what happening? Delay also increasing. This is the disadvantage. To overcome this disadvantage, what we did? We went to carry look ahead adder. We went to carry look ahead adder. So let's keep a heading carry look ahead adder. Carry look ahead adder. Carry look ahead adder. So in this carry look ahead adder, what we will do means we'll make a setup that okay, it will be independent. Means that whatever each and every flop, this flop is depending on carry. This flop is depending carry of this flop. Previous, sorry, not flop, full adder. This full adder is depending the previous carry. I want to make independent. All should be work parallelly. Okay, it should not be depend on anything. So how I can make that? Simple. 4 bits. I'm taking again same example. Full adder. This is C0, A0, B0, sum 0. So carry also it will generate, but leave that one. So then A1, B1. Not only A1, B1. One combo circuit will be there. So this is C1. A2, B2, B3, B3. So generally what they will do, some places, okay, this all together they will keep circuit. These are that we top or bottom, anything is fine. Getting? These all together they will keep. This combo circuit, okay, generate C1 carry. This combo circuit generates C2 carry. This combo circuit generates C3 carry. So now it is it depending on previous full adder carry? No. It only generating and it only calculating directly. How that will happen? That we need to be look into that. Okay. So this is the full adder. These are the full adders. How it is happening? So what is the carry equation? So we see two carry equations, right? One is carry equation, carry equal to AB plus CACA plus BCA. This is the one equation which is comes from the full adder. Okay, K map. Second equation is AB plus AXR B into C. This is the second equation. Okay, second equation. Both are same. So now, so why we are to this one means we will make that okay carry generation propagation process. Okay, so this AB will call the carry generator. AXR B will call the carry propagator. AB is we can represent as a G. AXR B we can represent as a P. So then what we will get? G plus P into C. Okay. So now I am looking for carry 0. Carry 0 equal to so this is for carry, right? Next stage of carry. So this if suppose carry I plus 1 equal to Gi plus Pi into this one is Ca. If I equal to 0, C0 plus 1, 0 plus 1 equal to G0 plus P0, C0. So 0 plus 1 means C1 equal to G0 plus P0, C0. This is carry 1 equation. So now I equal to 1. C1 plus 1 equal to G1 plus P1 C1. So means C2 equal to G1 plus P1 C1. But if this equation 1 will substitute in this equation, so what we will get? C2 equal to G1 plus P1 in this place. Okay. So G0 plus P0 C0. Okay. C2 equal to G1 plus P1 G0 plus P1 P0 C0. Okay, this is the equation. Equation 2. This is the equation 2. Now we'll go with equation 3. I equal to how many carries are there? 1, 2, 3 carries. So now, fourth carry directly I will take from here. no need to generate. Ready? So 3 carries I need to be checked. So I equal to 2. So C2 plus 1 equal to G2 plus P2 C2. Now C3 equal to, so substitute okay C2 in the place of okay whatever C2. So this equation 2 will be substitute. So then what we will get? G2 plus P2 directly P2 G1 plus P2 P1 G0 plus P2 P1 P0 C0. Get it? 3 equations are came, right? Yes or no? 3 equations are came. So now how I can write this equation? This equation how I can write? Carry generation C0 P0 C G0 P0 C0 is there. How I can write this equation? How I can write this equation? This equation I can write simply okay P0 C0 I need to give to the AND gate. This is P0, this is C0. This is AND gate, then G0 will be given to the this result I need to be given to the OR gate. This is the circuit. This is the circuit for this equation 1. So the same way equation 2, what is the circuit for equation 2? What is the circuit for equation 2? P1 G0 P1 G0 is both need to be AND. P1 P0 C0 P1 P0 C0. These 3 need to be AND. So then this result and G1 only, right? G1 need to be OR. Getting this equation is need to be write like this. So this equation how to write, you know, right? So now what happens? Okay, simple. What happened they will do? Now they will take one bigger combo circuit. They will take one bigger combo circuit. Okay. So they took bigger combo circuit. So now C0 directly will comes. C0 directly they will give. Clear? So what are other things are there need to generate? What are the other things are there need to generate? C1, C2, C3. So for C1 what I need to want? G0, P0, right? Yes or no? G0, P0. Let's consider. Yeah. This is A0, B0. Then what is this one? Yes. Propagation, carry propagation only, right? A XOR B means. A XOR B means what? B0. A XOR B means carry propagation only, right? So we should be this one only, right? B0 only, right? This one is P0, this one is G0. G0, C0, you are already giving. So then what we will get? C1 will get. Getting? How C1 will get means this circuit also need to add here. Getting? So this G0 circuit is there. So what is this? G0, C0 need to be add. How you will add? 100 gate. So then 100 gate, then OR gate is there, right? 100 gate. C1. C1. Why I use this formula means okay, we are going with okay half adder. Okay, half adder XOR and the AB easily will get. Okay, so we need only C in that already. We will get from the previous. Okay, starting. So generally at starting it will be 0. So that's the reason we will go to this. So next, if you exercise, if you go same. Sarge A1, B1. So this is a P1, P1, G1, right? P1, G1. So now what I need to do? This is P1 and how it is? How it is? C2. G1 into P1, G0, P1, P0, C0. Yes or no? So P1, G0. P1, this one only, right? P1, G0. So I'm connecting like this. P1, G0, P1, P0, C0. P1, what is that? P, P1, this is G1, right? P1, P1, P0, C0. P1, where is this P0? P0, C0. C0 is this one, right? Wherever class is there, there only connection will be there. This is one thing. Okay, next one. G1. This is a G1 only, right? This is all together. This is C2. Ready? So next step, say 3. You will be able to implement, right? It will take time. Okay, it will go with other topics. If you are not able to implement, let me know. I will go with that one. Okay. So this what you need to do. This you need to give to the full adder. Then it will carry is there. It will generate. So here also full adder it will give. It will generate. Here also full adder it will give. It will generate, right? Carry already there. Other inputs you will give. So it will generate, right? You have to wait for other things. All right. Directly carry is there. We are generating and we are propagating all working. Sorry. Mic is not working, right? Mics are not working. So these all are okay. These all are okay. So like this, we need to be implement and we need to give. Clear? Simple, right? So whatever is there directly, it will be generate the carry and it will give the stage. Means simply you are now implemented these combo circuits to generate the carry. Okay. Remaining setup is same. Remaining setup is same. You generated this combo circuit, it will generate the combo directly. It will work. Clear, right? So here no need to wait for any stage. Any stage or each and every stage is individual with other stage. Sorry, this is I think A0 P0. Correct. Okay, so this is the thing. Carry loop header. If you understand this, we'll go with BCD order. BCD. What is the full form of BCD? Binary coded
Decimal.
BCD means binary coded decimal. So in the BCD, how many numbers I can represent? 0 to 9 I can represent, right? After that, 0 how in BCD will represent? 0 how you will represent in BCD? 0 0 0 0. 9 how you will represent in BCD? 9.
1 0 0 1.
1 0 0 1.
1.
So 10 how we represent in BCD? Any idea?
1 0.
Huh?
1 0 1.
1010.
No. BCD. BCD binary coded decimal. Then how will represent?
1010, sir.
Will not present. That is hexadecimal. 1010 is hexadecimal. Getting? That is not a binary coded. 0001 0000. This is BCD. Clear? Not clear, huh? Binary numbers, if I will tell, we will understand that. But let's just close this, okay? So just 10 will represent BCD like this. 1010 is hexadecimal format, not a binary format, okay? Binary coded decimal will not be 1010. It will be like this: 001 00. So 1 will be separately will represent, 0 will separately represent. Getting? Now see, any two numbers you will take, any two numbers less than 10. Two numbers. 8 and 7. 8 plus 7. What is 8 plus 7? 15, right?
15.
8 plus 7, 15. 8 how we will represent in BCD? 1 0
1
0
0
0.
0.
7 0 1 1. 0 triple 1. Okay. These both will add 1. Any carry is there? No. 0 1 1 0 1 1 1 0 1. Is this is in BCD format?
No.
Is this one is BCD format? No, sir.
No.
For suppose small numbers you will take like 2 and for suppose 6. I'm taking 2 and 6. How much it is? 8.
8.
If I will represent, how I can represent in BCD? 0 0 1 0.
1 0.
6 will be how I can represent?
0 1 1 0.
0 1
1 0.
1 0. So no. So now if I will add this 0 0 0 1 1 0 carry 1 1 1 0 carry 1 1. This is in BCD, right? This is in BCD. This is not in BCD. So how I can make it in BCD format? How I can make it this one in BCD format?
Adding excess 3.
Add
Excess 3.
extra 3. Why extra 3 we need to add? Any reason?
For converting this into BCD code, no, sir. That's why.
Sorry, can you speak loud?
For converting, sir, to represent BCD code.
To represent in the BCD code, need to add extra 3.
3.
Okay. We'll add for this one. I will add. Okay, this is not in BCD, right? He's saying okay, adding extra 3 will be converted into the BCD. We'll see how we can represent 3. 0 0 1 1. We'll add 1 1 0 carry 1 triple 1 1 carry 1. So 0 carry 1 1 1 some 0 carry 1. So now this is 1. Okay, before this, okay, add the 3 numbers. 1. This is 2. This is becomes 12. This is becomes 12, but here it is 15, right? Then means adding 3 will not be the correct solution. Adding 3 will not be the correct solution. What is the correct solution?
Then add 6, sir.
Add 6. If 6 will not do work, then 9.
No, sir. Add 6. Actually, 6. Add 6, sir. But I said.
Why you need to add 6?
3.
Why need to add 6?
Why means.
That's where the people will be. Okay, that's what only. See, adding a number. We need to add a number, no doubt. Why that number we are adding? You should know. Getting everything have a reason. Why? First, need to be think that okay, someone is saying blindly. Why you need to be accept? without a logic, okay, you are studying the digital, okay, logic gates, okay, without a logic, okay, how blindly we will follow that? We are adding one number. Why we need to add that number? In hexadecimal, how many numbers will be there? 15 numbers will be there. Okay. So we are able to represent those 15 numbers in hexadecimal, in decimal format. After 10, okay, after 10, the format will be changed, right? 10 we can't represent in BCD.
Yeah.
11 we can't represent. 12 we can't represent. 13 we can't represent. 14 we can't represent. 15 we can't represent. How many numbers we can't represent which are present in hexadecimal? 6. 6 numbers we can't represent. That's the reason we need to choose 6. We need to add 6. Getting? We need to add 6. That will be hexadecimal. Okay, 15 we represent. But in the BCD we can represent 9 only. After that format will change. Okay, that format we need to correct it. How many numbers we need to correct? 6 numbers we need to correct. That 6 number we need to add here. So if you add 6, then it will be correct. See, everything you need to be think in a reason wise. Okay, don't blindly follow anyone. Not only me. Okay, so anyone, don't blindly follow. If someone saying should be a logical, then only we can accept. Getting? If I will say the iron will fly. Iron will fly means how it will fly? Iron will fly generally. Throw the iron, it will fly. No, right? So then, now aeroplane is flying, right? That is made with iron only, right? So then, it should be logical. Why it is applying? Because it is some force is applying. Okay, some logic is there. Okay, some angle will be there. So based on that only they can fly. So many things will be there. Okay, longitude, latitude they will check. These all things will be there, right? Not directly they can fly. So no. The same way here something is operation is doing. Why it is? Why only this? First why? Why it is? Why only this? Is there any alternative? Is there any alternative? If any alternative is there, why they approaches this process only? What is the differences? If you start thinking like this, no doubt when completed this course, okay, you will be in some good company. You need to question first. Getting? So now here, what we need to add? 0, 1, 1, 0. This is
0.
1, 1, 1, 0, carry 1. 1, 1, 1, 1, carry 1, 1, 1, 0,
1, 0.
1. So this before you can add 3 numbers. This is 1, this is 0, 1, 0, 1. That is 15, right? This 15, this 15 matching, right? This is the reason. So now this whatever we are saying, that is in the numbers we are saying. I need to be converted into the circuit. How the circuit looks. See. Before bit parallel adder. I'm taking 4-bit parallel adder. How many numbers I need to give here? A0, A1,
A2, A3.
Generally, it will represent from right to left. Okay, fine. Okay. So B3,
B2, B1,
B1, B0.
B0.
Let me represent this is also in correct way, right? Well, people will confuse with it. A0, A1, A2, A1. So now this one we are representing, right? So now from this, what we will get? Sum we will get, carry will get. So now inside carries will be there. Finally, we will get only one carry. This is the one final carry. Okay. So this is the one final carry, C out carry. And how many sums we will get? 4 sums we will get. S0, S1, S2. We will represent this one inside. S0, S1, S2, S3. So now these are the four outputs we are getting. With respect to these four outputs only, I need to process it. Yes or no? If you see, four outputs I am getting after adding the two numbers. Four outputs I am getting. These four outputs after getting only, I need to do some process. If it is a binary BCD, I don't want to do any process. If it is not in the BCD, I need to do some process to change it. Yes or no? So how I can do that? How I can do that? That is the main important. So this is the four is there. If I will go with the K-map, okay, how many variable of K-map I need to implement? Four variable of K-map. Four variable of K-map, how many things will be there? 16 things will be there, right? So no, 16 things will be there. This is S3, S2, S1, S0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the thing. Clear? So now, how many numbers we can't represent? How many numbers we can't represent? From 10th we can't represent, right? 10 we can't represent, 11 we can't represent, 12 we can't represent, 13 we can't represent, 15, 14. These numbers we can't represent. So now these numbers, okay, I need to map. 16 variable can I first I need to check for 16 variables, can I map or not? 16 I am able to map? No. So then 8 I am able to map? No. So then 4 I am able to map? Yes. So this is a 4. This 4 if I will map. What is the common in this 4? What is the common in this 4? S3, S3, S2, S3, S2. Any other things are there? No. Next I need to map. So how many variables I need to map? 4. Next also we have 4 variables. This is the 4 variable. Okay. So from this what I will get? What is the common? In this S3 is common. S1. In this S3 is not changing. Here S1. Here S1. S1 is not changing, right? S1 or S0? S1. S1 is not changing. Okay. S3, S2, S3, S1. This is the equation we will get. Ready? This is the equation we will get. So this equation, what you need to do? You need to do like this. S3, S2, S3, S1. Now see. This is the S3. Then S2. So now I need to be conjugate. Then again S3. S1. This is also conjugate. Clear? This both I need to give to the R gate. Clear? Any questions here? Any doubts? No, right? Now again one more 4-bit parallel adder I will get. This will be goes like this. One more 4-bit parallel adder. So now this whatever will come, okay? This is 0. Means this bit default 0, this be default 0. Okay. these bits, these both bits will comes from this combination. Getting this combination, these two bits will comes. So this is already S3, S3, S2, S1, S0. This number it will add, and it will give the output. Outputs it will give, right? Z3, Z2, Z1, Z0 outputs it will give. Clear? So if we carry, here also will comes, right? Carry, what I need to do this carry? Ignore. Ignore this carry. This is the final carry, not this one. Here, whatever the carry will come, this carry, don't worry about this carry. Clear? So now take the example, any one number, tell me, any one number, A1 number, B1 number, tell me. Fast. Any one big number. 1, 0. A I will take 9, B I will take 8. We'll see big number. Okay. So 9, how will we represent? 1, 0, 1, 0, 0, 0, 1, 8, 1, 0, 0, 0. Okay. So now see. A is 1, 0, 0, 1. B is 0, 0, 0, 0, 1. So now if these both I will add, okay, by using 4-bit parallel adder, what is the result I will get? 1, 0, 0, 1, 1 is sum 0, carry 1. Okay. So means carry here will get carry equal to 1. So remaining numbers are 0, 0, 0, 1. Reading 0, 0, 0, 1. So now what I need to do? So now this one is going, right? So now this one is 0, this one is 0. Both are 0. What I will get? Both are 0. 0. This one is 0. Next, these both are 0. These both are 0. 0, 0, right? So what is the R gate will get 0. So here it will 0, 0. Something is wrong. This only something is wrong. Represent correct one, right? S3, S2, S1 is 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. 4 variables play map. In these 4 variables, S3 is common. In this 2, S1 is common. In this S3, S2 is common. So why this one is not common? Nine will represent like this only. Get the truth table of this one first. Write the truth table. BC truth table. One how will represent 0, 0, 0, 0. 0 will represent 0, 0, 0, 0. Zero, 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 1. Okay. So 1. So 2 how will represent
0, 0, 1, 0.
3, 0, 0, 1, 1.
1, 1.
4,
0, 1, 0, 0.
5, 0, 1, 0, 1. 6,
0, 1, 1, 0.
0. 7
0 triple 1
1 1 8 1 0 0 0 9 1 0
1 0
0
0
1 1 0 0 carry 1. This one is carry 1. This carry is very nice. 7 2 5 What is this? BCD, right? BCD also. Yeah. This is the problem. See, I corrected it. One thing I missed. One thing I missed. This is the output carry. This is the output carry. This carry need to be connected to OR gate. This is the problem. Getting? This carry need to be connected to the OR gate. So this carry need to be connected. Okay, so last one carry is there. This carry is 1, right? This both are 0. This becomes 1. This both are becomes 1, and the code will be corrected. Okay. So means what we need to add? 0 0 0 1 1 0. So this becomes 1. This one becomes 1. This one becomes 1 0 1. Before we'll add 3 numbers. Then what is the result we'll get? 1 and 7. 17. So no, the same thing will get. So one thing I miss is this one need to be connected to this OR gate, and this is the carry. Clear? This is the solution. This is the BCD order. Understand? Any questions? Any doubts here? It's class 7:30 only, right? So we'll go in this topic. We will note down these things. Note down these things. Then we'll go with the next topic. Sorry? Combo circuit. Combo circuit. Yes. Completed. And then just simply take the screenshot and keep in the group. That's it. Okay. Don't keep in the group. Management is there. If you want, you can share here along version. Means that is simple solution. So no need to wait for class complete. You can take screenshot from online. Yeah. So we'll go with next topic. What is the next topic I told? Multiplier. Multiplier. Adders are completed. All type of adders I told. Clear? Adders subtractors completed. Let's go with multiplier. Multiplier. What is multiplier? Definition? Anyone? What is a multiplier?
Converting single input to multiple outputs.
What is? That is a mux. That is a mux. Mux is different, multiplier is different. Mux is different. Mux is different. Multiplier is different. What is a multiplier? Multiplier is used to multiply binary numbers. Okay, it is a combinational circuit. What it will do? So, if for suppose 2 by 2 multiplier, I am saying 2 by 2 multiplier, two numbers. Okay, two numbers with 2 bits. We need to be multiplying two numbers with 2 bits. Means A will have 2 bits. A1, A0. B will have 2 bits. B1, B0. 2 bits will be there. So now, for suppose consider, so I want to do 12 into 13. I want to multiply. How I will multiply? 3 into 2, 6. So means what I will do first? 3 into 2 I will do. Then 3 into 1 I will do. Next. So this position is completed. That's why this position I made class. So then 1 into 2, 2. 1 into 1, 1. So then 6, 5, 1. Same thing we need to replicate. That's it. Same thing we need to replicate. So how I need to replicate? Okay, A need to have 2 bits. Let's take 1, 1. B need to have 2 bits. Let's take 0, 1. So what is the output I will get? 1 into 1, 1. 1 into 0, 1 into 1. 1 into 1, 1 into 1, 1. Next, 0 into 1, 0. 0, 0 into 1,
0.
0. Then
0.
1,
1 1
1, 0.
1.
Right? So now, in place of this 1, 1, so let's go with the A1, A0, B1, B0. Keep A1, A0, A1, A0,
B1 B0.
B0. So now multiply B0 into
A1
A0
A0
will get here. So next, A1,
B0 A1
B0. So next, this position is completed. B1, A0,
A0
A0, B1. So next,
A1 B1 B1.
so now this one is product P0. This is product P1. This is product P2.
P2
P2. Okay. So if any carry will comes from this, that is product P3. Getting? So now any carry will be possible from here to here it will go. Any carry will possible? Any
No.
carry will possible? No.
No,
Why?
sir.
Because 2 bits if I will multiply, I will get single bit only. That is 0 or 1. See, y equal not comes with 0 into 0, you will get 0. 1 into 1, you will get 1 only. Yes or no? Yes or no? So that's
Yes,
the
sir.
reason. So this first one will not give any carry, no doubt. Directly it will be go to the product. But so here 1 bit is there. This is 1 bit. This result 1 bit. This result 1 bit. 2 bits are there. If both are 1 1, these both I need to be made plus, right? This both I need to make plus. Then what I will get? I can get the carry. I can get the carry from here to here. Carry will be present. Carry will present here. Okay. This carry plus this. If carry is 1 and this result will be 1. 1 plus 1. Again I can get the carry. But first case only will not get any carry. Clear? So P3, P2, P1, P0. What is the equation for P0? P0 equal to A0, B0,
B0.
P1 equal to
A1 B0
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 plus
A0 B1
B1.
B1
Then P2 equal to
A1
A1 B1.
B1
P3 equal
maybe
to carry, which is comes from P2. P2 carry.
sir, then P2 also carry వచ్చే అవకాశం ఉంది కదా సార్.
P2 also will get carry. A1 B1 it will comes carry here. Getting? But in this case only carry will not come. So if you want to write, you can write okay P0 carry. P0 carry also. Here P1 carry. Here
సార్ P1 కి క్యారీ రాదు కదా.
P1 carry will comes, right? This is product result will be 1. This result will be 1. 1 1 0 1 can be generated, right? So that carry will comes P1.
What I'm saying, P0 carry should not be right in P1.
P0
P1 equals to
it should
A1
not
plus
have
B0
carry.
plus
Sorry.
A0 B1, right, sir?
This one you are saying, sorry. This one is not. This is P0 carry. This is P1. Yeah.
For P2, P1 carry.
This one is P0. This is P1 carry. This is P2. Okay, P1 carry. This is a carry. So carry or P2 carry can write. P2 carry. Getting? Here we will not get any carry. This P1 carry will get. P2 carry we will get. Clear? So if this one is one more time I will write, right? P2 will confuse. If carry I will write, just see. P0 equal to, there is no carry, nothing, right? A0,
B0.
Code out this. P1 equal to A1,
A1 B0
B0 plus
plus A0
A0
B1
B1.
plus
This one will generate the carry. P1 will generate the carry. P1 product will generate the carry. P2 equal to
A1
A1 B1
B1
plus
plus P1 carry.
P1 carry. Okay. P3 equal to directly
P2 carry.
P2 carry. P2
Carry.
carry. That's it. Clear? Clear? Any doubts are there? All right. So let's implement this in the circuit format. Let's implement in this one in the circuit format. So first A0 B0. So take A0 B0 both under gate. So then this one will be
A0 B0
directly
No.
output B0. So next one is A1 B0 A0 B1. A1
A1
B0
B0
A0
B0
B1. This both I need to give to
or gate.
really? Really? Yes. OR gate I need to give a. Yes. You are doing logical addition or binary addition? Here you are doing logical addition or binary addition?
Logical.
Huh? What is the difference between logical addition and binary addition? Recall. Already told. This is the trap. This is the trap. If I want to ask the interview digital, okay, how much knowledge that guy have, I can ask this question directly. If I will ask, okay, many people will fall. No, logical addition, binary addition, both are different. In the logical addition, OR gate 1 plus 1, what is the result? 1.
1
Getting? Binary addition, what it will happen?
1 0
1 plus 1?
1 0
Sum 0 carry 1. In the binary addition, 2 bits adding what circuit we will use? This is one bit, right? This is one bit. This is one bit. This is all. These are two binary bits. I am adding. What I need to use? Two binary bits. I am adding. Half adder. Getting? Two binary bits. We are adding half adder. We need to use. Not a or gate. This is the trap. Remember. Note point. Note down. Note down. Half adder. What it will generate? Sum it will generate. That sum will be P1. Carry it will generate. That carry will go to the stage. What is the next stage we have? A1, B1, right?
Yes, sir.
A1,
A1.
B1. So this we will give. This carry will give to the this. Okay. So
Same half adder.
here, what I need to use again? This both adding.
Half adder.
Okay. This is P3. Sum is P3. Carry is P4. That's it. This from this to this. This is MSB. This is LSB. Clear? This
Yes,
is
sir.
the 2 by 2 multiplier. Remember, see, when multiplier will come, okay, people will specifically ask why you are using half adder. Why not OR gate? You are not representing the circuit. Means what I am saying here, you are adding two binary bits. Getting? Adding two binary bits. You are not generating the logic. You are adding two binary bits and that product you are taking. How you will add means to binary bit added device is in the combinational circuit is half adder without carry. Here without carry we are adding. With the carry is there, then full adder I need to use. Getting? This is very, very important. Understand, right? This is the main point you need to be remember. Clear? Now we'll see how much you remember, how much you understand. 3-bit means how many will be there? We will have A2, A1, A0. We will have B2, B1, B0. If I will multiply this. If I will multiply directly, I am going. Okay. B2, A1, A0 into B2, B1, B0. So that A0, B0, A1, B0, A2,
B0.
This position is completed. So A0, B1, A1,
A1,
B1,
B1. A2, B1. B1.
A1. Then
A0, B2,
A0,
A0.
B2,
A1, B2,
A1, B2,
A2,
A2, B2, A2,
B2.
B2. Clear? This is a product 0, product 1, product 2, product 3, product 4. This will not create any carry, but this will create the carry. Yes or no? This will create the 2 bits are there, will create the carry. Okay, this one also create the carry. Getting? This one also create the carry. This one also create the carry. This one also create the carry. This is product 5. I need to implement this in the circuit format. How I need to implement this in the circuit format? Equation first you need to note down the equations. What is the equation? P0. P0 equal to A0, B0. P1 equal to
A1,
B0 plus
A0, B1.
P2 equal to
A2, B0.
A2,
A2,
A2 B0 plus
A1, B1.
A1 B1 plus
Plus A0, B2.
A0
B2.
B2.
2.
So
Plus P1 carry.
P1
Carry.
carry. So this here P0 carry will not come. Okay. P3 equal to
A2, B0.
A2
B1.
A2
B1.
B1, right?
A to B1.
Into B1 plus
A1 B2
A1 B2 plus
plus P2 carry.
then P4 equal to A2
A2
B2.
B2
A2 B2 plus
plus
P3
P3 carry.
carry. So P5 equal to
P4 carry. Carry.
carry. Clear? Any questions here? Any doubts? Clear, right? So let's represent this. A0 B0. B0 product 0. So then A1 B0 A0 B1. A1
Is
B0 A0 B1.
B1.
A0 B1, right? So these both, what we are doing? Half adder. Related to
Right.
half adder. You get sum
Sum.
6 3 1.
One.
Carry we will wait. This carry will be here. Carry will be here. We'll wait for that. This is a half adder. So next up, A2 B0, A1 B1,
B1
B1
A
carry
naught.
only we can do. Getting this is A0 B2 will be keep separate. Why? Because we need to do next time. Getting see full adder what it will add maximum we have full adder only. Okay, it will add 3 bits. This is 1 bit. This is 1 bit. This is 1 bit. Or this bit, this bit, this bit. Okay, any 3 bits it will add. Okay, 2 bits with the carry it will add. Okay, other bit extra bit is that we need to be make one more full adder we need to make. How that I will tell you. Okay, so first A to B0. A2 B0 A1 B1. So then A0 B2, right? A0 B2. I think circle will not sufficient here. Okay, we'll see, we'll see. So then these 2 bits with carry only I can do, right? This one, this one, this one. I need to give the full adder. It will generate the sum. This sum will be P2. It will generate the carry, this carry. Okay. This carry. And what we are getting? This carry and P2. We already represented this on this side. A2 B0, A1 B1, A0 B2 plus P1. Now this carry is there, this carry and this one. To whom I need to give?
Half header.
Huh? 2 bits only, right? What I need to give? Sorry, wait. This is wrong. P1. This is wrong. This is not a P2 product. Guys, this is not a P2 product. Wait. See, this is not a P2 product, right? Because
Yes, sir.
circuit is not completed. This B2 A0 is left out, still left out. So this whatever sum will come, this carry and this all together, we need to give one
Full
more.
adder.
So now whatever will come, this is P2. Whatever carry will be there, this is for rest. Getting?
Yes, sir.
Getting? Understand, right? 2 bits. See here, 4 numbers and 4 bits I need to add. That's why 2 full adders are used. Getting? Sum also need to give to same thing, carry also need to give to same thing. Then whatever the final will get, that one will be P2. So then this one will be carry. So now next to one, what is there? P3 is there, right? Get this to be removed, right somewhere. So next step, A to B1. A to B1. A1. A1. B2 and P2 carry already present. Okay, this is the P3 equation. So now this result, and this all three together I need to give to the full adder. So whatever will come, this one is P3 carry will wait. So now A2, B2 and P3 carry. A2, B2, see, straight lines you can draw and you can tap from there. Okay, that is also you can do, or you can take like this is easy. That's why I am going like this. Okay, so P2 carry. Here, how many bits I need to use? 2 bits. Yeah? 2 bits. This is 1 bit, this is 1 bit. Which one I need to use? Half adder. Getting? Half adder. Half adder will have how many outputs? 2 outputs, right? One is P4. One more one is P5. Carry sum. This is the circuit. For 3 into 3 multiplier. Clear? Any questions, doubts here? Sorry? 4 full adder will not be there, right? 4 bit parallel adder. 4 bits will be there in that. 4 bits will be there. Okay. But how we can use here? There, how many bits are there? 4 bits. 2 bits, 4 bit parallel adder, what it will do? 2 numbers with 4 bits it will add. Getting 2 numbers, 4 bit it will add. Here we have only 3 bits, right? So no, 3 single bits we have. Not understanding. This is a 3-bit number. But if you observe here, this is a 1 single bit. 0 or 1. This is a 1 single bit. This is 1 single bit. 3 single bits. Getting? 4 bit means what? 4 bits will be there. Getting? Don't confuse and don't make me also confused. Clear? Any questions here? Any doubts? Understanding, right? Multiplier, understand, right? What is the time? 8. 1 more 15 minutes are there. We'll
Sir,
go with
anyway,
marks. Sorry?
Anyway, this is a multiplier, sir. Before that one is adder, na?
Sorry. You
He
repeat
asked
again?
that that is a 4-bit adder, but this one is multiplier, na? I must say.
Yeah. This one is multiplier. So now we'll go with marks. Up to this, adders are completed, multiplier also completed. So now we'll go with marks. Simple brief introduction I will give. So next class, same thing I will repeat. Don't think that okay too much. Just if you want to be insert, you can insert. Otherwise, leave it for today. Okay. So marks I will repeat tomorrow again. Mux multiplexer. Generally, the full name of Mux is a multiplexer. Multiplexer. So what is the multiplexer? Multiplexer means simple definition you need to remember means many to one. Many to one. Simply many to one. Now, in the desktop, when I open this laptop, in the desktop, many things are there, right? I open Salesforce. I open Salesforce. Many things are there. In that, I selected only one thing. That only process and it will give. Yes or no? Same thing. Many to one. Many to one. So here what we will do multiplexer. Many inputs will be there, but only one output it will give based on I also selected. When I selected only that the input is that output is came, right? Based on the selection line. Based on the selection line. Many to one based on the selection line. Getting? This is also called as data selector. This is also called as data selector. In interview, no one will ask, okay, explain marks. Explain data selector. What's that? Sir? Sorry, sir. Sorry. Data selector. No one data selector. Okay. So data distributor. Two things will be there. Data distributor is Dmux. Data selector is this one. Clear? Now see. Multiplexer. Multiplexer definition is simple. Many to one based on the selection lines. If selection lines are n, selection lines are n. So then inputs are 2 by n. Output is 1. Output is 1. Selection line inputs are n. Sorry, selection lines are n. Inputs will be 2n. Output will be 1. So now I am saying n equal to 1. N equal to 1. So then what will happen? One selection line will be there. Two inputs will be there. One selection line I am saying S0. Two inputs will be there. I0, I1. One output will be there. That is Y. This only will call 2:1 marks. 2:1 marks. If n equal to 1, then 2:1 marks. N equal to 2, 4:1 marks. N equal to 3, 8:1 marks. Getting? So how these are came? Why two inputs are there? Because 0, if selection line is 1, that is S0 can be represented in the 0 format or 1 format. Means this S0 I can write 0 or 1. That's why 2. If two selection lines are there, 0, 0, 0, 1, 1, 0, 1, 1, 4 combination will come. That's why 4 inputs. Getting? Clear it? Very simple. Nothing will be there. It's like curd rice. Getting? So next, now if we go with this, okay. So now, what is the truth table of this? What is the truth table of this? Selection line is 0, output is Y, right? Selection line is 0, output is Y. Selection line is 0. What is output? I0. Selection line is 1. I1. Y equation Y equal to S bar. S bar, S0 bar. I0 plus S0 I1. This is the equation. This equation how I will implement in the circuit format? S0 bar, S0 bar. So now S0 bar, then I0 I1. So now S0 bar I0, S0 bar I0. So next S0 I1, S0 I1. This both. Here I am not binary addition I am doing. Here logical addition I am doing. Getting? Not a binary addition. Understanding binary addition, logical additions. Here binary, where the binary numbers involved, okay, their binary addition will do. Here any binary numbers we are involving? No, right? 0 plus 1 we are doing? No. This logic plus this logic we are doing. Previously if you observe here, this is a two numbers product, this is a two numbers product, these both are adding. Two binary bits we are adding. Here, two logics we are adding. You think difference is there? This is a OR gate, this is Y. Clear? This is the circuit. Any questions, any doubts here? Any questions, any doubts?
No, sir.
Very easy thing. At least you need to remember this. This equation, these things. But no one will ask Marx definition and Marx equation, right? No one will ask. Interview, no one will ask. This much silly question they will ask. They will not ask. You are a PD engineer. Yes or no? PD engineer means a person who is greater than AI. Simply, if I want to say greater than AI. So AI which is not able to do that work will be done by PD engineer. Clear? That the work will be done by PD engineer. So now n equal to 2. N equal to 2. So when n equal to 2, how the circuit will be? Two selection lines will be there. S1.
4 input
S0,
lines is there.
0 0
0,
1
1, 0,
0 1 1
1, 1.
I0 I1 I2
I2, I3,
I3. Output
Y,
is
Y.
So you need to go with the truth table. So then circuit implementation you need to go. What is the equation for Y? Let's write the Y equation here. Y equal to S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus
I3 plus S1,
S1 S0.
S0, I3.
This is the equation. Based on this equation, you are not able to represent. You can represent like this, right? Circuit. Simple. Clear? Any questions, any doubts? But no one will ask this. No one will ask this. They will ask, can you implement AND functionality using Mux? Can you implement AND functionality using Mux? Now, my question is, already we have AND gate. Why we need to implement the AND functionality in Mux? Where we will use this? This one only will use in the PD in ECO stage. Engineering change order they will say. Okay. Engineering change order they will say. There are two types of ECOs will be there. Functional ECOs and functional ECOs and timing ECOs. Functional ECOs, timing ECOs will be there. There they will add extra logic to enhance the performance. Sometimes what happened to enhance the performance from RTL itself, it will not come. When you are exiting the chip, right? Then they will say we need to be add some more logic here to enhance the performance. So they knows at the end they will add the some logic. That's why what they will do at starting itself only they will add some spare cells. Spare means what? Extra. Extra cells they will add. In the extra cells, they added 1 mux for suppose consider. 1 AND gate, 1 OR gate, 1 NAND gate, 1 OR gate, 1 mux they added. AND gate, OR gate, NAND gate, NOR gate, all are already used. Only mux is there. But I want AND functionality. In here, this is the spare cell group here. So I want here 1 AND gate functionality. Here. Somewhere here we'll have one more thing, but here to here going and come back, it will be create, so timing problem for me. So here to here only one mux is there. I need to be implement AND functionality. they will ask implement and the functionality using 2:1 marks. Okay, first I will go with inverter, you will understand. Then we'll go with the AND gate OR gates. Okay, so inverter or NOT gate. Using 2:1 marks. So now this 2:1 marks I need to implement. Okay, inverter NOT gate functionality. 2:1 marks. How many selection lines will be there? One selection lines, two input 0, 1, one output, Y will
Y.
be there. This is the 2:1 marks. So now inverter means what? Inverter means it will be like this, right? So now A will be there, output Y will be there. A is 0, Y is 1, A is 1, Y is 0. Clear? Now selection line is A. If A is 0, Y is 1. A when it is 0, Y should be goes to 1. Means I need to connect to VDD. That only right, output will charge and it will becomes 1. So A is 1, A is 1, 0. I need to connect to VSS. This is the inverter functionality. One input is there, one output is there. If A is 0 I am giving, so then output becomes 1. A is 1 I am giving, then the output becomes 0.
Power.
Clear? This is the inverter, okay, implementation by using mux, inverter functionality. So now same for AND gate. AND gate, how many inputs will be there? Two inputs will be there, right? A, B, Y. What is the truth table? A, B, Y, 0, 0, 0, 1, 1, 0, 1, 1. Any one of the input is low, output is low. 0, 0, 0, 1. Clear? So now same functionality I need to implement by using mux. I have one selection line, two inputs are there, one output is there. So 2:1 mux is there. Okay, so this is the thing. Now the question is I have two inputs, but only one selection line is there. How I can pass this 4 outputs? How I can do that? Any guess? Any guess? How we can do that? Any guess? How we can do that? Any guess? No. No. Any guess? Any guess? What is the second
Yes,
statement of AND gate?
Sir, A can be taken as selection line.
A can be taken as a selection line. Good. Okay. Tell me.
B, okay, like
What is
VDD
the
and
second statement of
VSS B.
AND gate? Any one of the input is 0, output is 0. No need to check for another output, right? If A is 0, what is the output? Output is 0, right? So then what I need to connect?
VDD.
Yes. A is 0, output is 0. I don't need to be worried about this. If A is 1, so then I need to worry about this. Whatever B is 0, output is 0. B is 1, output is 1. If A is 1, that's it. That's it. Yes or no? If B is 0, I am giving 0, we will get. B is 1, I am giving 1, we will get. Yes or no? I am implementing or not? Okay, this is A selection line. If I will go with B selection line, then B selection line. Now tell me.
Same.
What is same? B selection line.
0.
B is 0. This case and this case, no need to worry about A. A will be. We are not worrying. This is VSS. So now, if B is 1, whatever A is there, the same thing. A is 0, 0. A is 1, output is 1. So that's it. Simple. Any questions? They will ask this one. They will ask 2 is to AND gate, OR gate, NAND gate. If this one also not sufficient, he want to check more in depth of your knowledge. So then what they will ask? They will ask implement full adder sum using 4:1 marks. Full adder carry using 4:1 marks. That is the top level. Means depth. Depth they are asking. Clear? Simple. Few things will be there. There people will be trapped. Like multiplier circuit, mux. Okay, mux multiplier they will confuse first thing. Second thing in multiplier, okay, binary addition they will think okay logical addition. This is the second trap. Okay, and third one is this one implementation when inverter they can implement, but coming to the okay, so AND gate OR gates they will feel little bit difficulty. So then full adder functionality sum carry means won't give them. Next class full adder, how the sum we can represent, carry we can represent. Okay, so 2:1, 4:1 max, how we can implement by using 2:1 max. This is all things skills. Clear? Max is very, very important. Max at least we need to take 3 classes. Clear? So then we'll go with the DMAX.